Okay, so for number 5, we have y equals the natural number of to the power of x squared. Remember the rules, yeah. So if I have e power something, so if I have y equals e power something or e power functions, the y exponent will equals to e power fx itself. You never change the e, and then you multiply by the chain rule, the power. Okay, so we know that the y equals e power x squared, right? So the y exponent will equals to the number itself, e power x squared, times by the derivative of the power. Okay, so 2x, right? Okay, so we can get 2x e power x squared, or you can move to the left to make it easy. So that's the dy dx. Okay, part 1 we are done. I think I need to copy this to Microsoft Word as well, so you have also the written explanation. Okay, give me a moment. Wait. Oh, he's coming. A moment, please. I will move this to the left. Okay. Hi, Vicky. I think you can hear me right now.
Yep.
Okay, nice. So we just discussed about number 5. Number 5 is like this. I will repeat one more time. So when given that y equals e power x squared, find dy dx, what you have to do is using the formula. This is the formula. This is the basic formula on the left side. So on the right side is the question. So if we have e power something, e power functions, so the derivative is e power functions itself. You don't have to change anything of e, and multiply by the derivative of the exponent, or using the chain rule method. Okay, so times by the derivative of x squared. What is the derivative of x squared? 2x. Right, and I just move the 2x to the left side and e power x squared to the right side. That's for the first number. Now let's go to the second number. It is number 7 1 until 7 part 2. Okay, let's go to the next part. 7 part 1 until 7 part 2. Okay, a curve is such a point is such that dy dx equals blah blah blah. The curve passes through the point 1 over 2 comma 5 over 6. Here, this is the dy dx. Okay, dy dx. Find the equation of the curve. I don't think your teacher teach you this. This is not the derivative question. You are asked to find the integration version. Have you ever learned about the integral or integration?
No, not yet.
So number 7, part 1 and part 2 are totally out of the topic. Okay, because the given part dy dx, you are finding the y, blah blah blah. See, that's a huge problem. Okay, but oh, I see. We can look at the curve. Oh, I see. I see. Sorry. I did something. I read the wrong question. So a curve is such that dy dx. So this is the curve. So the curve passes through the point 1 over 2. Find the equation. Oh yeah. Okay. So 1 over 2 is the x, and this is y, right? So the dy dx, or the gradient, right? If you want to find the equation of the curve, you need to find the gradient first. Okay. So the gradient will be. Wait. No, I think we cannot do this. No, we cannot do this. Why? Because the given part is dy dx, you are finding the y. If you get the y and you are finding the dy dx, it is a derivative. So, but for the switch part, if you switch the question, you are given dy dx and you want to find the y, it is integration. So this is totally out of topic. Yeah, I'm quite sure about this. So for number 7, I and part 2 is wrong. I mean, out of the topic. So you need to learn the other method. Okay, I will skip this because this is integration. You have to make sure with your teacher, ask him whether this is a right question or not. Is it an out of topic question in my opinion. Why? Because you have to find the y, not the dy dx. Okay, let's go to the next part. I see. Shoot. So this is another 7. Okay. Okay, so let's do this. There you go. You can do this as easy as that. Okay, given that the curve has an equation of y equals 1 over x plus 2 square root x, where x more than 0, okay, you don't have to think about this. Find dy dx. Ah, piece of cake. I think your teacher gave you the previous number 7 is the other number 7. Okay, so let's say y equals x power -1, right? Remember, you have to change this to change the notation of the indices, x power half, right? So to find dy dx, it's quite simple using the adding or subtracting rule. Okay, use the regular rule. Dy dx or y accent will equals to -1 x power -1 minus 1 -2 plus 2 times, because this is the constant will remain there, plus at times half times x power -half, right? 1 over 2 subtract 1. So the answer will be dy dx or y accent will equals to -x squared plus x power -half, right? So that's the first answer. The second answer, the second question is asking you for the second derivatives. So you have to derive this one more time. Okay, derive this one more time. -2 or d square y over dx squared, the notation of the second derivative, or y double accent will equals to.
Where did the negative on the exponent go?
Oh, here.
On -2.
-1, subtract 1, right? If you derive this number.
Yeah, for the answer you put 2 instead of -2. It's supposed to
Oh,
be 2
thank
then.
you. Thank you.
Okay.
Thank you so much. I did something wrong. So x power, okay, I have to be very, very careful. -3, right? And then plus -half times x power -half minus 1. -half subtract 1 is -3 over 2, right? And that's all for the answer. Or if you want to make it more simple, you can write like this: -2 over x cubed, right? -half x power 3 over 2. 3 over 2 is 1.5, right? And you can make it to in indices form or search form, SURDS, 1 over 2x square root x, because this is x1.5. But again, it's about your preference. I think this is enough.
Is it supposed to be positive? Because the x is negative and then you times it by -2.
Wait, yeah, my goodness, thank you so much. 2 -1 times -2, because yeah, I haven't correct the bottom part. Okay, thanks. So I will erase this also. Thanks for the correction. And this is plus also here, right? No, it's already negative. Okay, negative. So plus half times -half. Plus 1 times -half. Okay, so this is unchanged. Okay, and that's all. So both are right. Okay, depend on what your preference is. But I think the first answer is still okay. It's already okay. Okay, next. Okay, wait, I have to more focus on this. Okay, part 3, no need to do part 3, right? The question is asking you for until 7.1 and 1.1 II. Now number 10. Aha, okay. So we deal with the trigonometric derivative. So I want to write on the right side of part of this paper. So if I have y equals sine x, wait, y accent. So when y equals sine x, the y accent or the derivative of y is cos x. And if it is cos x, it is negative sine x. If this is tangent x, I already proved this as second square x. So you don't have to memorize the quotient rule of tan. Okay, cos 2x, we have the functions. So if I have sine fx, the y accent will equals to cos fx multiplied by the inside, the derivative of inside. How about cos fx if I have cos fx, it is negative sine fx as usual, but don't forget to multiply by the inside. Why it is like that? Again, my honest question is, I don't know where it comes from, but it just happened to be like that. Okay, how about tangent? Tangent fx is second square fx times by the derivative of the inside, or the angle. Okay, that's it. So we have 6 formula that we need to memorize, and the other formula is just using a regular or standard rules. For example, cos 2x. So we have the multiplication rule, u equals cos 2x, right? And then v equals sine 1/3 x. I just write like that. We use the product rule, right? And then you put u accent. I ever seen Vicky write like this, u and u accent. Besides, up to you. It's about your favorite. Which one is your favorite? In my opinion, going down is better, but in Vicky's opinion, going right is better, and it's no problem at all. Sine 2x. Don't forget to multiply by the inside. Okay. So we have to do it super detailed and slowly but sure. And v accent will sine equals cos, right? So the derivative of sine equals cos 1/3 x. And don't forget to multiply by the inside. The derivative of the inside, I mean. See, the chain rule. Now you can get the formula u accent v plus u v accent for the product rule, right? So cross multiply. No, not cross multiply, but do the crossing formula here. U accent v. Okay, so I just write negative 2 sine 2x times sine x over 3, or sine 1/3 x. I think this is better for our understanding and for the visualization. And then plus by, I use the other color, better blue, u v accent, right? So 1/3 is in front. I just put it in front of the equation here, and then cos 2x times cos 1/3 x. That's it. Okay. Now I think I need to copy this print screen. Why? Because I don't have enough space for part 2. No, wait, something missing. Then wait a moment, please. Okay, I need to copy all the formula. Okay, now let's go to number 11, to 10 part 2. Again, this is tan and ln. Okay, you have to memorize. If I have y equals ln x, the y accent is 1 over x. And if I have ln function of x, or ln of something not as simple as x, the derivative of the ln x is 1 over fx multiplied by the inside. Right? Ln is always 1 over. Ln is always 1 over. But if you have the function inside the ln or ln, you need to multiply with its chain rule, the derivative of fx. It's the same, right? Totally same. But in this question, we only need to use the first formula. Okay, let's go. So this is a quotient rule, right? You have to write down u equals tan x, v equals 1 plus ln x, right? So u accent is second square x, as simple as previous. The v accent will 1 equals 0, so plus 1 over x. No need to change the inside. Or what is the derivative of inside? The derivative of x is 1, right? So you don't have to do anything. Multiply by 1. And then the quotient rule formula. U accent v minus u v accent over v squared, right? That's the quotient rule formula. Write it down. Second square x. Wait, sec square x times 1 plus ln x minus tan x times 1 over x. Or I put 1 over x in front. I think that is better. 1 over x times tan x, right? Over 1 plus ln x squared. And what next? I don't think we can do anything else. That's all. Okay. But if you want to make sure that if you are OCD enough to see second square is 1 over cos square x, right? 1 plus ln x minus tan is okay, 1 over x times sine x over cos x over, but I don't think it is necessary. But again, it will become like this when you face the multiple choice question. I can get of 1 over cos x. So the rest is 1 over cos x, 1 plus ln x, right? Factorize the number, minus sine x over x. Wasting time, but again, we have to prepare for the worst. Log ln x square. That's it. But I think this is already enough. Okay. Next, if you have any question, just ask me, or if you find my mistake, please let me know, because sometimes I miss the details. Okay, next. Yes?
Can I ask how, wait,
Yeah,
I
sure.
just got, how do you get from here to here?
Oh, here. If I get 1 over cos x, so the remaining will be sine x over x, right? I factorize the 1 over cos x out of the equations. Okay, get it? Okay, so I don't think it's necessary again, but I try to give the worst case scenario. Okay, next. What number? What else? 10. Wait. 10 done. 7. Another 7. See, add that. Okay, another 7. No. 9. No. 7. Another 7. Yeah, there you go. Okay. So another 7. Differentiate this. Okay, we use the product rule. Right. What is the product rule? Ux and v plus uvx and keep it. I already preserve the formula. So the u is x power 4. The v is e power 3x. So the uxn will 4x power 3, right? The vxn is the number itself, e power 3x. You don't have to change anything. Multiply by the inside, the power, multiply by 3, using the e rule, right? The natural numbers rule. So yxn equals uxn v. So for, wait, what's that? 4x cubed times e power 3x plus 3x power 4 x power, wait, e power 3x. I just keep the x in front and the number, or the e on the last part. You can just switch like that, as easy as that, because it is multiplication. Again, if you are looking for the simplest answer, you can get the x power 3 out of the functions, out of the equation, to factorize, I mean. And then e power 3x also can be get rid of both of the equation. So the rest will be 4 plus 3x. Done. Right? You factorize, do the factorization. Now, how about this? Ln. Okay, you memorize the formula. Ln functions of x is equals of, not equals, derived to 1 over fx times fx and x. Okay, that's the idea of natural number, ln, natural log, ln log of natural number, ln log natural. So 1 over the answer, wait, 2 plus cos x, multiply by the inside. The inside 2 becomes 0, right? Plus negative sine x, or minus sine x itself, right? 0 plus minus, so minus sine x itself. And then you put on top to make it more simple, right? If you have any question, ask me. I do it quite simply. You can look at me doing this question simply because I already struggle with this for about for some years, and this is your first part. So feel free to ask me. I never underestimate the first the newbies questions. Okay. After we do number 7, we do number 12. One more. Okay. This is the quotient rule. We haven't done number 10. No, 7. So this is u equals sine x and v equals 1 plus square root x, or I just put x power half, right? So the uxn is cos x, the vxn is 1 is 0. Okay, so the rest will be half x power negative half. So the quotient rule, uxn v minus u vxn. So we already, I think you already familiar with all the formula. Okay, I already repeated sometimes on your first meeting and the second meeting. So cos x times, don't forget to put the bracket as always, 1 plus square root x. Just make it simple because I think this is what is the satisfying question answer. Minus u sine x times half x. Oh, okay. X power negative half is, I think I can just do like this, right? It can be written as this. There you go. Yeah, bit negative below, power is on the denominator, and half is square root over v square. 1 plus square root x square. I think that's all. No need to make it further. Don't make this answer longer. Okay. Next. After we do number 7, what else? 12. 9, no. See a curve. No, this is integration. If you look at something that like I call touching worm, see, so it is integration. It's more annoying than derivatives. 12. There you go. A curve has equation, blah, blah, blah. Find the set of value of x for which dy over dx is more than or equal to 0. Okay, so you have to find dy dx first. 3x squared minus 18x plus 24, right? And then it is more than 0. So 3x squared minus 18x plus 24 is more than 0. So you have to find the sets of the values. I divide by 3. See, make it simple. And then x squared minus 6x plus 8 more than equals to 0. I forgot to put the equal sign. Okay, and then do the factorization. I get it the number easily. Minus 4 and minus 2. Okay, because we factorize by using the sum and product rule. Sum and product. What multiplied by what? What number multiplied by what number equals 8? And if it is sum up, it will get negative 6, right? So it is clearly seen for negative 4 and negative 2. So we have the zero maker here, 2 and 4, right? And the curve is frowning or smiling. A is positive, right? A is positive 1. So if A is positive, remember, the curve will will facing downwards or smiling. Yeah. There you go. This will be our rough graph. It's not detailed. And the question is asking you for the number or the derivative that is more than or equal to 0, the positive side. So this will be the positive. This will be the positive, right? So below the graph, below the x-axis is negative, above the x-axis is positive. So the answer will be x less than equals to 2 or x more than equals to 4. This will be your satisfying answer. Okay, so you need the help of a previous logic, previous understanding about the quadratic functions. Okay, this is quadratic functions. Next, 12. Oh man, I think I need to the normal to the curve at the point. Okay, so we are having the next question. I need to use this. A moment, please. I need to use this sketchbook because we need the previous question in order to solve the next question. Wait, where are you? Ah, there you go. Wait, here. So for question 2, the normal to the curve. Normal, remember normal? The normal is always negative reciprocal to the tangent, or always perpendicular to its tangent. So where x equals 3, what is x equals 3? What is the gradient when x equals 3? You can find it as simple as this. So the dy dx equals to, wait, it's too dark, too light, is equals to 3x squared minus 18x plus 24. Don't use the simple one. Yeah, you have to use the row derivatives. So when x equals 3, the gradient of the tangent, right, is equals to 3 times 3 squared minus 18 times 3 plus 24. And okay, I'm finding my calculator. There you go. 27, right, minus 18 times 3, negative 27 plus 24, negative 3. So the gradient of tangent line is negative 3, but the gradient of normal will equals to, remember, negative reciprocal. You switch, the negative becomes positive, the 3 become 1/3, right?
So
And yes,
when we find the normal, you always have to find it from the derivative. Yeah.
there you go. That's right. Normal is always the first derivative, and you have to do the negative reciprocal rules. Okay, good question. The normal to the curve where x equals 3, cut the y-axis at point P. Okay, so you need to find the point of the normal first. Okay, when x equals 3, the y equals here, right? So where x equals 3, so the y is equals to 3 cubed minus 9 times 3 square plus 24 times 3. So 27 minus 9 times 9, 81 plus 24 times 3, 18. So the answer is 3,18. And we need to find the equation of the normal first. Okay, we have to find the question, 2 questions in one part, and the coordinates of P. Okay, coordinates of P cut y-axis, so it means that xp equals to 0, yp equals unknown, right? We have to find on the next step. But again, we need to find the equation first. So the equation with y equals minus y1 equals m x minus x1. Have you learned about this, or you learned about the other one? Which one do you use? Mx plus c, or this one, left or right, or both?
Right.
Right. Okay. So I'll have to skip the left side. So this is the x and y. This is the gradient, right? Don't use the tangent gradient. Careful, because the question is asking for the normal. So y minus equals mx plus c. The y is 18, m is 1/3, x is 3 plus c. Okay, 18 equals 1 plus c, so the c will equals to 17. And the equation will be y equals m 1/3 x plus 17. That's it. Okay. That's the equation of the normal, using the normal, the gradient, and the point. The point is always at the curve. And part 2, coordinates of P. So cuts the y-axis at point P. So y equals 1/3 plus 1/3 x plus 17. For point P, the xp, so the yp is equals to 1/3 of xp plus 17 also. So yp is unknown, right? Equals 1/3 of 0 plus 17. So the yp as simple as 17, right? So the point P is equals to 0, 17. That's it. Okay, just pick the number 0 given, right? Cuts the x-axis. When it cuts the y-axis, cut the y-axis, the x is always 0. So this is the part 2, question 2. Okay, we have to find 2 answers on part 2. Okay, I will copy again. Do number 12. What else? Wait. After you do number 12, what question you need to do? 6. Okay, we even haven't reached the halfway. 6. Okay, skip. There you go. I see. This is also same. I will give you the shortcut. I mean, I don't want to do it all because I know that you can do the rest later on. Okay, so this is U, right? The V is, we use the product rule, x squared minus 12 power 1 over 3, right? So the U accent is 1, the V accent is 1 over 3 or 1/3 x squared minus 12 power 1 over 3 minus 1 is negative 2 over 3, right? Times by the inside 2x, right? Then the dy dx, or the gradient of the tangent line, right? Always tangent, is U accent V. Like it is 1 times x squared minus 12 power 1 over 3 U accent V plus U 3x times 2x, 2 over 3x, right? I make it simple, 2 over 3x, right? U V accent x squared minus 12 negative 2 over 3, and you can find the gradient of the tangent where x equals 2. Okay, so you just use a calculator. I will show you how to use the calculator. My students said I have too much faith in calculator because I just put the number row, and they are quite insecure with that. Okay, a moment, please. Oh, there you go. Okay. So I put x as 2, right? 2 square minus 12. I ignore the 1 because 1 is nothing more than not changing the value. Power 1 over 3, right? But don't forget to put right one more time, plus x is 2 times 2 over 3 times 2, right? Close bracket, and then open bracket again. Oh, okay, I need to put the bracket here. I also insecure with what I'm doing right now. Okay, there you go. So this one plus 2, I put the bracket again, times 2 over 3x times, there you go, x squared 4. Yeah, I just can do it like that. 4 minus 12 to the power of negative 2 over 3. Ugh. The calculator is working so hard. Negative 4 over 3. Okay, thank God we get the answer. Negative 4 over 3.
Hans.
Yes.
All right. Where I get this from?
Oh, chain rule. Okay. Right. Be careful about
if
this.
you do the derivative of this,
Mm-hmm.
you have to add the
Times, not add.
n first at the beginning.
Yep, sure. And the power 1/3, and U power n minus 1, 1 over 3 minus 1 is 2 over 3, and multiply by U accent by this derivative of the inside. Remember the chain rule, yeah, Vicky?
Yeah.
Okay, nice. Can go forward. So M normal is 3 over 4, right? Negative reciprocal. And where x equals 2, what is the y? So where x equals 2, the y equals 2, you put here 2 times 4 minus 12 power 1/3. Okay, 2 times negative 8 power 1 over 3. Negative 8 to the power of 1 over 3 is negative 2. Okay, so negative 4. So the point is 2 comma negative 4. And you can write y equals mx plus c. That's all. Because the question is asking for normal. Is this? y equals mx plus c, you get the m, you get the c, and you put back to its form y and x. I don't think I need to continue this, okay? Because you know how to do. Because I already did just now on the previous question. Okay. Wait, I think I need to put extra. Do it yourself. Okay. We haven't done for this question, but I know you can do it. Okay, this is for the sake of time. I don't know whether we can finish all, but try the best. Next question. We done number 6, 10i. No. 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 There you go. Oh my goodness. Okay, let's do. Oh, I think it's quite long because you have to parallel between two equation. U equals 2x. The v equals x squared plus 21 power half, right? I will explain and then I think Vicky can understand right now after this because I do it twice. So uxn equals 2 and vxn is half, right? Half x squared plus 21 times a power, don't forget, half minus 1 negative half, multiply by the inside 2x, yeah, x squared 2x plus 0. Or you can simply put like this, x over square root x squared plus 21. Okay, this will be your answer. Oh, I mean your vxn. So the answer is using quotient rule, right? So the yxn equals uxn v, subtract u vxn over v squared. Y xn. Uxn v 2 square root x squared plus 21, right? Minus u vxn 2x times x over square root x squared plus 21. You put the over thing again, v squared x squared over 21. Okay. Now, okay, because square, right? V squared is, you can ignore the half. Now we need to find until this part. So that's the challenging part. What next we can do? This is over 1. Okay. If this is over 1, you need to make the denominator equal. I can put 2x times x equals 2x squared. Right? It's more simple to see. And y equals over square root x squared plus 21. Right? This one. Look what I circle. I am doing this first. Okay. So what you need to do on the left side, times square root of x squared plus 21 times square root of x squared plus 21, right? So 2 x squared plus 21, right? Minus, I almost forget minus here. Minus 2x squared, done. And look at the blue part. I have to finish this, right? X squared plus 21. Now you can finish this. I think you can just do 2x squared plus 42 minus 2x squared, right? You open the bracket and do the rainbow rule over square root of x squared plus 21 times 1 over x squared plus 21, right? Here. Okay. You can erase and you will get the simple constant. K is 1, right? So K is 42, I mean. So 42 over, this will equals to, look at this. Look at this carefully. The question is quite tricky. It's still not equal to the top side, but we know that on the left side can be written as x squared plus 41 squared, right? Man, it's so challenging. There you go. 42 over. Why your teacher give you such question, man? I hate this. It's so hard. Done. Okay, by the way, it's hard. I have to admit that I am guessing. I doubt your teacher in class teach you this kind of question. Did he teach you about this question previously in your class? Hello?
No.
No,
I don't
see,
remember.
Right now.
Yeah.
he's so offside right now. The question is harder than what he taught.
It's
And
like with this teacher, he teaches like the basics in class, and then
see,
homework is hard, and then test is like
hardest.
something so different.
Yeah. So like from extraterrestrial question. Hence five. Oh, no need. Okay. Part two is integration 5. One. No. 8i. I think we have to go 5. 5. Where is 5? Ah, there you go. Find the equation of tangent. Oh, tangent. Okay, we don't have to put into normal. Yeah. Careful. This is only tangent. So stick to the rules. So y x1 equals, very simple, using the subtraction rule. 3x squared subtract 1 over x, right? This is ln x. At the point where x equals 1. Okay. So where x equals 1, the y xn will equals to 3, 1 square minus 1 over 1. 3 minus 1, right? Okay. At last. So the gradient of the tangent will equals to 2. And where x equals 1, you have to calculate the y, right? So where x equals 1, the y equals 1 cubed minus ln 1. So if you get confused about what is ln 1, you might use calculator, but I know the answer is 0. But you need a decent understanding about the natural log. Ln 1 is 0, yeah? So there you go. I just proved that this is 0. So 1 minus 0 is 1, right? So the point will equals to 1, 1. The equation for tangent, okay. Y equals mx plus c, using this rule. Y equals mx plus c. 1 equals 2 times 1 plus c. So 1 equals 2 plus c, right? C equals negative 1. After you get the c, put back to its original. Y equals mx minus 1, right? Okay, y equals mx plus c. That's the answer. I hope that this kind of question will get will be a majority of your question later on, not the previous one. Next, number 5 done. Now, let's go to number 8i. Oh man, I forgot to do this. Okay, show that it is bisecting. What is bisecting? It is reaching or cutting. Yeah, cut the value, cut the answer, cut the point, or going through that point. Okay, wait. Show that this tangent. All right, wait. Show that this tangent bisect the line joining. Bisecting means it cuts. Okay. So -2 and 16 and 12 over 12,2, the line joining points this. So you have to find the other line equation. So first thing first, you have to find the m, right? y2 minus y1 over x2 minus x1, right? 16 minus 2 over -2 minus 12. So it is 14 over -14. Oh, piece of cake, -1, right? And you can pick any points. I think I want to pick 12,2. Why? Because no negative. Put y equals mx plus c, right? And then y equals 2, -1 times 12 plus c. So 2 equals -12 plus c. The c will be 14. The equation of this line will be equals to y equals -x, right? -1x plus 14. And when it bisects, they share the same point, right? So here it is bisecting. So when it is bisecting, it has to be equal in all the properties of points. So y1 equals y2, right? 2x minus 1 equals negative x plus 14. So the 3x will equals to 15, x will equals to 5, right? And y is equals to, you can put anywhere. I think I can put here. 10 minus 1, 9. Okay, 5, 9. And you can prove that bisecting means they share the same distance, right? Remember the formula of midpoint? Man, midpoint of this. Xm, ym. Midpoint is x1 plus x2 over 2, y1 plus y2 over 2. It requires you to squeeze your brain and you have to go back to secondary 2 formula or grade 8, the gradient or the midpoint. Man, so negative 2 plus 12 over 2 is 5, right? See, it's proven. And 16 plus 2 over 2 is 9. So it is proven also. So it is proven, yeah. So we just try to prove that this line and that point. Okay, for example, I will give you the GeoGebra formula. I mean the GeoGebra proof. So the gradient, I mean the equation will equals to, wait, there we go. Y equals to x minus 1. The tangent, right? And next will be the equation of the other equation of the line that we obtained just now. Okay, negative 2, 16. And then 12,2. Look at this line. If I connect this, it will be in y equals negative x plus 14. See? And this will be the bisect. Intersection is the bisection. Okay, the midpoint. My goodness. Okay, I will copy this. It's too far. It's too far. For part 2, yeah. Not the other part. Part 2 is so annoying. There you go. Okay, it's proving. The proving is already there. Okay, continue. Oh, wait. What else? Okay. One more. I think some more numbers. 8. Is it 8? Oh, 5. Still have 5 number. Okay, I think you can do this, right? Just using the quotient rule. I just give the clue, yeah? Because I think I need to go over all. So the quotient rule, the u equals x squared, the v equals 2 plus x squared, the u xn is 2x, the v xn is 2x also, and you need to use the quotient rule, u xn v minus u v xn over v squared, and you have to, I think I don't have any term, you have to paksa this into this term, and then we are done. Okay, I think we already done, by the way. Oh, quite simple. U x and v here, 2x, 2 plus x squared minus x squared times 2x. And the bottom part is already equal, see? Okay, thank God, it's easy. Yeah, there you go. Okay, and then y xn will equals to 4x. No, wait, 4x minus 2x cubed. and then minus 4x cubed. Oh no, minus 2x cubed over 2 plus x squared bracket square, and you can cross out. Okay, yxn. So k is 4x, right? Done. 8i done. 4 more numbers. If I get this kind of question again, I just skip this. Okay, I just skip the other questions. I hope that we have another
Nico
question.
has,
Yes.
how did it become minus?
Oh, the formula. Formula, right? There you go. Minus. Oh, this one.
Yeah.
Yeah. Thank you. This one is positive. It's still, anyway, it's still crossed out. Thanks for the reminder. Okay, so we can get rid of everything here.
Okay.
And then notate clear. Fine. Okay, next. It's on it. And then what else? 12. No. No. Man, it's even not half. See what I'm dragging. 8i. Okay, you can do it using the quotient rule. I mean, sorry. I mean product rule. Yeah, product rule x times ln x cubed. You remember ln x cubed is a function. So I will give you this. U equals x, v equals ln x cubed, and uxn will equals to 1. Vxn is 1 over x cubed times by the inside 3x square. Yeah, so 3 over x vxn. You can cross this one, and uxn equals 1. Why I have to write it down? So the y equals uxn v plus uvxn, and prove it is equals to this. Okay, next. One more minute. 6. Where is number 6? Low number 6. I'm finding number 6. 11. No. Okay, everything is almost the same. Number 6. Where are you? Ah, there you go. Using quotient rule. Okay. U equals tan 2x. Be careful about the derivative of the trigonometric value. Second square 2x, not x, multiply by the inside 2. And the v will equals to x, the vxn will equals to 1 using the quotient rule. Y xn u xn v minus u v xn over v squared. Done. Part 2, equation of the normal. So you can find the y. This is the gradient of tangent, right? And then put the negative reciprocal. You will get mn, negative 1 over mt, right? And then where x equals pi over 8, you can just put calculator in order to find the y, as we did before. But this is in terms of trigonometric value. No need to be worried about. Okay. Again, just use calculator. I think your teacher will give you the chance of using calculator, unless we are all die to do this kind of trigonometric value. Next, one more. 4. No, part 3, yeah. Okay. One more. 4. 4i. Oh, piece of cake. I like this. U sine x, v cos x. U xn is cos x, v xn is negative sine x. Careful. It has to be negative because the cos. Using the product rule. So the y xn equals u xn v plus u v xn, done, right? Cos square x plus, wow, negative sine square x, or cos square x minus sine square x. right? And then we are done. If you want to go further, you can. Remember the rule? 1 equals sine square x plus cos square x, but I don't think you need to do that. Oh, in terms of sine x, oh my goodness, you have to do that. So cos x will equals to 1 subtract sine x square, right? 1 minus sine square x minus sine square x. So y equals 1 minus 2 sine square x. There you go. In terms of sine x, not cos x at all. Okay.
And
Yes.
if okay, so if it's like sine x, that's not a function, right? So you just no need to times the derivative. But
Yeah.
if it's like sine 2x, that's a function.
That's 2x is a function. Okay, good question. So if I have sine 2x plus 2x squared plus 5x plus 3, make it more harder. Okay, let's say this is y. So the y action will be equals to sine becomes cos, but the inside don't change it yet. Multiply by the derivative of the inside, chain rule, right? This is the function. So 4x plus 5. Yeah. Okay, that's it. If 2x or cos 2x, so the y action.
What about the derivative? I mean, not the but the
Mhm.
exponent.
Oh,
Like,
the e part. So if I have y equals e power x, the y action is also e power x. Don't change anything because it's an exponent or e. Okay. If I have y equals e power 3x, so the y action is again e power 3x. Don't change anything, but it has to be derived to the chain rule times 3. Right? Get it, Vicky? I already explained that on the first on our.
I mean, for like here, there's no exponent like the n minus 1.
Oh no, because you have to derive 2 going down, right? So 4 2 minus 1 is 2 itself, right? It's x itself. Yeah. Okay, so we're done. And we're done for everything, but some of the question is not explained totally. And please let me know whenever you have any question. I will answer it 1 or 2 more hours because I have another meeting after this. Okay. So good luck, yeah. I hope you get a good score for tomorrow.